So, welcome to this content. Is that what this is? This is YouTube content. You're watching me on YouTube. You want content, we're going to give you content. We got this question from Kavitka, who says, how would you secure an API without any sort of user login? For example, your front end hits a third-party API using an API key. Since you can't securely store the API key on the front end, and you can't, some people might think you can, but anything that's on the front end is exposed to anybody that goes to your website. So you actually can't hide things on the front end. You move that API call to a Node backend, but is there a way to prevent others from accessing your API? Now, there are a few things you can do, but I will say, ultimately, aside from actually adding user and password, well, adding like user authentication to your own API, which in turn is calling the other API, aside from doing that, there's a few things you can do to prevent people from like spamming your API and potentially like running through your rate limit. Like you can actually rate limit users. You can also increase the length of the responsive requests. So like each request they make takes a little bit longer, and it discourages them from overwhelming your API. And then you could potentially create one-off API keys yourself on your own API. There's a lot of things to do, but I think the first thing that we're going to do is we're just going to set up a backend that actually makes a call to an API. And we saw here we're going to use the NASA API. You can read about here, they have rate limits on how often it can get called. And basically the issue here would be if someone found your NASA API key, API key, they could potentially use that API key and use it so many times that you lose all of the potential remaining requests that you have. And so if you hide that API key on your backend can cache requests and basically prevent people from seeing the actual API key. And what I demonstrated is we're using the demo key here, and we have now been rate limited because the demo key is limited to 30 requests per hour. So I actually need an API key to make sure that it works. Now, technically, you probably could just make a request directly to the NASA API from your browser. Like, let's see really quick. If we go to their image API, which I don't think requires an API key. Yeah, and if we look at this, does it have CORS headers? Which would mean you technically could just make that request. Yeah, it does. So because this images endpoint actually responds with access control allow origin star, that means that you could request this code directly from your front end. There's no need to put this on a backend. But because we want to hide our API key, which that's the reason we're going to put this on a backend. So first thing I'll do is just generate a simple backend server. For that, I'm going to use create express API. We're going to call this NASA API Proxy. And this is an example of a proxy. So a proxy is something that essentially takes in a request, does something with it, or potentially forwards that request to someone else and then forwards that response back to you. So we're going to build a backend proxy server. We're going to build a backend API that will make requests to get the weather on Mars. It'll get back that response, and then it will respond to whoever made that request. So if we go into NASA API Proxy, we have a basic Express app. Let's check it out. Yeah, a man in the middle on purpose, but it's a man in the middle so that it could do things like hide your API key or cache things or different stuff like that. I generated, this is a very basic Express app generator that I created. It comes with some tests and some basic things, but we basically just have an Express setup. We've got our API mounted at /API v1. And if we take a look in there, we've got some emojis endpoints. So if I start this thing up, we're going to get a basic API. Oh, I have to change the port because I have other things listening. So we can see in our index that it defaults to port 5000, or it looks at process.env.port. So I'll go ahead and create a .env, and I'll set my port to be 4545. That's like NASA, isn't it? I don't know. 4545. And so now if I start it up, we now have an API running locally on port 4545. If I go to /API/v1/emojis, it responds with an array of emojis. Very good. But what I want to do is I want to create some custom endpoints. I want an endpoint that's API v1/Mars weather, something like this, and that will respond with the Mars weather. So let's get that set up. I'm going to create a folder in here called Mars Weather.js. It's going to be very similar to the emojis router. But basically, when we make a GET request to /Mars Weather, we're going to this is where the proxy comes into play. So step 1 is we will make a request to the NASA API, and then step 2 is respond to this request with data from the NASA API. So basically, when someone hits our API, we are then going to call the NASA API. We're going to get back the response, and then we're going to send that response back to whoever made that request. So that's basically what we're going to do in this route. For now, we're just going to respond with a message that says, hello, Mars weather. So there's that. There that. 6262? That's possible. I'm going to leave it what it was. So I have this Mars weather router. I need to now mount this router in my full Express application. So I'm going to do that in my API index, just like I did with emojis. So we're going to bring in Mars weather. We're going to do bring in that specific Mars weather file, and then we're going to use it. So we're going to say router.use at /Mars weather. We want to use that Mars weather router. And I'm actually going to do dash case. So what I'm putting right here is whatever comes in the actual URL after /API v1. So I'm going to make this Mars-weather, like that. And just like that, we should now have an endpoint that responds. So now, if I make a request to API v1 Mars weather, it's going to respond with an object that says, hello, Mars weather. Great. Now what I need to do is I need to make the request to the NASA API. And so we tested, this is the actual URL we need to hit, but we need to put our own API key in. And thank you, Randy Horton, for those 100 bits. Much appreciated. Okay, so we will do that here. I'm going to store this URL. We'll call this like the base URL. And Randy, again with the 100 bits. Thank you very much. So that's the base URL. And then we can actually wrap all of these params into some URL search params. So I'll say the params are, we'll do this inside the request. New URL search params. And Randy with another 100 bits. Thank you very much, Randy, for all the bits. And basically, we're going to create some key value pairs that have all of these things inside of it. So we're going to have that. We're going to have feed type, which is JSON. And we're going to have version, which is 1. Randy with another 100 bits. Randy with all the bits. Thank you very much, Randy. Awesome. So these are the parameters that I need to call on this endpoint. But instead of passing in demo key, I actually want to pass in my specific API key. Randy with another 100 bits. Thank you very much, Randy. So what I need to do is I need to get an actual API key and load that in here. And this project is already using a package called .env. So technically what I can do is I can say process.env.mars, API key. And Randy with 1,000 bits. Thank you so much. You're too kind. I appreciate you. So what this says is we're going to read NASA API key from my environment. And I'll show you right now, we have a super basic .env. We're just specifying the port. But in here is where I will put my API key. I'm going to go get the real value, but the real value is going to go in here. And this is stuff that I set up earlier, but if you look in the app.js, you can see that it's already bringing in .env, which is a package which will attempt to read in this .env file if it exists, and then put those variables on your environment. Someone in the chat asked about where API v1 is specified. That's specified right here. So this is like the root of my Express app, and we're putting all of the API endpoints behind API v1, which is why when we look in here, it's API v1 emojis, API v1 Mars weather. Cool. So I'm going to hide my screen for a split second. Randy with more bits. Thank you very much, Randy, for all the bits. Funny dude with 1,000 bits. So much support. So much support. Thank you, everyone. You were basic, like... I'll say this. I'm doing this for a YouTube video, but the amount of bits that you've given me is more money than I would make in YouTube ads for like several thousand views. way more, and I appreciate you. This is why I stream on Twitch and why I basically don't really make YouTube videos, because people support me here, and I appreciate you. What am I doing? I'm getting my actual API key. So what I'm going to do is I'm going to go into that .env file where I specified that like junk API key, and I'm going to put a real API key. That's what I'm going to do now, and you won't be able to see it. Hopefully, hopefully I'll keep it hidden. So I'm setting my API in. So in that .env file, I'm setting it. And thank you very much, Callum, for those bits. And now I think we're ready. I think we're ready to make it happen. Bald bearded builder, what's up, dude? Who says it must be crazy windy outside because those clouds are moving. Yep, that was the Denver skyline. Here, it's a time lapse. I don't know. What is time? Okay, so like I mentioned, I put my real API key into that env file, so now when this route gets hit, it's actually going to have something. Now, from inside of this API, I want to make a request to this other API. And for that, I need... I could technically use some core modules to do it, but there are some NPM modules that will make my life a lot easier. So I could use Axios, I could use Node Fetch, I could use... many other things. I'm going to use Axios because it's the one that I'm most familiar with. But basically, we just need something that will allow us to make HTTP requests. So I'm going to install Axios, just like that. And now that we have it, we can bring it in. So in this particular endpoint, I'm going to bring in Axios from Axios. And then now we can make the request. So when a client makes a request to our server at API v1/Mars weather, it's going to go into this request handler. We're then going to make a request to the NASA API. So I'm going to make this an async function. And we're actually going to put this in a try catch because it's possible that their API will fail. That the API call will fail. So I'm going to try and then catch it. If there was an error, then I'm going to forward it on to my error handler, which will automatically respond and set the right status code and all that good stuff. Okay, so I will say we're going to extract out the data from axios.get. We need to make a GET request to that base URL. Followed by these params. And I can just do that. That will automatically call toString, and that will turn these URL search params into a query string separated by ampersands. So that should make the request. And then once I get back the response, I'm actually just going to respond with it. I'm just going to say res.json data. So basically, a GET request comes into my server. I then make a request to the NASA API here. I get back the response, and then I send that response to the client that made the initial request. Now, if I've done everything correctly, this should just work. Now, whenever I request from my local server API v1 Mars weather, that should respond with the Mars weather. So behind the scenes, it actually made the request to the NASA API, gets back the data, and then it responds to the client here. But you'll notice there is no API key in the URL, right? So I technically could write a front-end application that calls this endpoint, and that way nobody can see my API key. It's hidden behind the scenes. And this gets back to the actual question that was asked, which is there a way to prevent others from accessing your API? So at this point, we've protected the API key. At this point, it's behind the scenes. Nobody can see it. I could put this this Express API on the web, and people could make requests to it. However, people could technically spam this endpoint, right? You could write a script that just hits this endpoint over and over again, and eventually it would exhaust my rate limit for the NASA API. So there's a couple of things we can use to help with that. And so I'm going to point you to the Express rate limiter. And then there's another package that's very similar, which will allow you to increase the timing of a response if people are making tons and tons of requests. So the first one is called Express Rate Limit. And also, yeah, caching is another thing. Thank you, Unicorn Hunter. So right now, and I'll show you this. Right now, if I refresh the page, technically that makes another request to the NASA API and then sends back the response. But what if, I mean, this is the weather on Mars. I probably only want the latest data, like, what, every 10 minutes or something like that? So we could create a cache. I think I'll start there. Caching is probably the first step to reducing the number of requests to the API that you're calling. And I'll just do this. I'll say the cache, and in this case, it could be very simple. I could just say cached data. And that starts off as it having no value. And what I can do is I can say at the beginning of this response here, and also I could store like the cache time. So I'll say if cache time is a thing, and the cache time is greater than right now plus some offset. So let's say we want to refresh the cache every 30 seconds. So I'll do 30 times 1,000. So, no, I'll do minus. So the current time, I messed up. Minus 30 seconds. Current time minus 30 seconds. If the cache time is less than that, then I want to get the latest data. And actually, so if the cache time is greater than that, then I'll return the cache data. That's what I'll check. Because otherwise, because then I can just do return res.json with the cached data, like that. So basically, this will first check, hey, are we in the cache? And if we are, just return that cache data. But then if we're not in the cache, we're going to make the actual request. Right here, I'll say cache data equals data. And then I'll say cache time equals date.now. And that way, the next request will use the cache data. And technically, to be consistent, I should like put a return here and put a return here, so we have consistent returns. And I think I did this comparison right. And let it be known that this is just a in-memory cache. And this is okay right now because it's very simple. But if you're calling a lot of different API endpoints, you may not want to do this in memory. Because basically, I'm just holding on to this variable. And if the API ever goes down, I will have to make a request again. You can store your cache in something like Redis or MongoDB. This is like the simplest way of doing it. Okay, let's see if this works. And also, we're going to just attach a property to it to let us know that it worked. So we'll say data.cachetime equals cache time. Hello, Wolfie. So now if I make this request, it has to hit the API because that's the very first request. And if we go all the way to the bottom, the cache time. So the cache time is Wednesday, June 24th at 10 a.m. GMT -6. And if I refresh this, because it was less than 30 seconds ago, we can see that the cache time is still stored there. And if I'm clicking refresh now, right now, and it is instant, like it's instantly happening. But in about 30 seconds, when I make the request again, it's going to have to request the API again. And there we go, it did it. So now we can see that the cache time is like right now. It is Wednesday. So this is like the first form of protection is instead of hitting the API all the time, you can now cache it in memory. Now you also could use a database or something like that. The next step is rate limiting. So Express Rate Limit is a package that I've used. And I like it. There are other packages that will do a very similar thing, and I'm also going to show you Express Slowdown. But Express Rate Limit is very easy to set up. You basically just say how many requests you want to allow a given IP address per time window, and it will throw errors if you request more than the amount that you're allowed. So I'm going to install this in my backend here, Express Rate Limit, and then we can set it up on this particular route. So we can say rate limit, we're going to bring in, and yeah, this is definitely something you need to do if you're deployed like on Nginx. I think you might even need this on Heroku. App.set proxy one. So trust proxy. So if you set that in app.js, like when your app first spins up, what that says is when your app is behind a proxy, the proxy will typically set the header that says X forwarded for. And that is actually the IP address of the requesting client. And this says we should trust that header because this code is actually running behind some sort of proxy like Nginx or whatever else, or a load balancer. Okay, so we're trusting that, and when we deploy, that should make sure that we're rate limiting the right IP addresses. If we don't do this, it's possible that we rate limit local host because it's behind a proxy, and then every single request is rate limited instead of just each individual IP address. Cool. So now we set up our rate limiter, and we can set up a time window. So we can say every 30 seconds, I want to allow 2 requests per IP address. Now you can increase this, you can decrease this, but basically what this will do is it will keep track of the number of requests that have happened for the route that you set it up on. And if someone exceeds more than 2 requests in the past 30 seconds, they're going to get an error. They're going to get a 429, which is too many requests. And I believe, we can just set it up like this. So if you're not familiar with Express middlewares, you can actually just put them right inside of your routes. So we're saying we request the route. Right now we just have the handler. But if I put this rate limiter right in between, now we have essentially rate limited that endpoint. So we've said that only 2 requests can happen every 30 seconds. And if more than that happen, then it's going to throw an error. So let's try it. So now if we go back, I should be able to request once. We get the data. I request again. But if I request again, too many requests, because that's more than 2 requests in the past 30 seconds. So basically the rate limiter is preventing people from spamming your API. So we have a couple of levels of protection. We're now caching the data. We're now limiting the number of requests that people can make. And then the other thing that I like to do is express slowdown. And so this really discourages people from spamming your API because it will essentially increase the timing of the response for every request that they make. So if they send like 10 requests back to back, each one is going to take a little bit longer to respond, which is nice. So let's install this. Express slowdown. And it works in a very similar way. And I believe it's from the same person as Express Rate Limit. Yeah, same person. It's great. It works. I've used it for many things, and it works wonderfully. So we'll set this up as well. We're going to add that here. And then we're going to need to set up our speed limiter. So I'm installing these in the backend. So this particular project is an Express project, and it has a package.json that's keeping track of all these dependencies. So you can see there's Axios, Express Rate Limit, Express Slowdown. And whenever I deploy this, it will see that wherever I deploy it to, it'll see that package.json and know what dependencies to install. Okay, so we need to create a speed limiter. And so I'm going to do over... And actually, I'm going to allow 10 requests every 30 seconds. So that's the limit that I'm going to do. And then I'm going to allow... well, for each request over the next 30 seconds, I'm going to increase it by 100 milliseconds each. So, and we're going to do... and we're going to delay it after the first request. So, after the first request, every request after that will be, the response time will increase by a certain amount. So I'm going to increase the response time 500 milliseconds. That way it will be like really noticeable, because after the first request, it's going to take 500 milliseconds more to respond with the next one. Then it's going to respond with within a second, then 1500 milliseconds, and then 2 seconds. So it really, really slows down the responses and prevents people from spamming your endpoint. So I'm going to first do the rate limiter, so that prevents a certain number of requests. And then after that, I'm going to do the speed limiter. And so we're now going to allow 10 requests within 30 seconds, and within 30 seconds, each subsequent request from the same IP address will be slowed down by 500 milliseconds. So now we should get back some data, and then it'll take 500 milliseconds to get back some data, and then a second to get back some data. You can watch the thing here to see how long it takes, and then 1500 milliseconds, and then 2 seconds. Actually, it'd probably be better to show this like Insomnia, because you can actually see the response time. And essentially by doing this, we're discouraging people from spamming requests to our server, because our server will slowly get less and less responsive to that particular IP address. So the response time here was 249 milliseconds, then 500. Then we should see 1 second. You can see the total response time here, and then 2 seconds. And then 2.5 seconds. So basically, if this was a baddie, if this was a bad guy who was just spamming our API, they would slowly be slowed down. But then after 30 seconds, they're no longer limited. Then it goes back down to the original response. So I think these are the main things that you can do. You can do rate limiting, slowing down requests, caching. On top of this, you could also create your own API keys. And so I'll show you how you would do that really quick, but all of these things I'm showing you, you could basically get a database involved as well, because right now, these are only limiting by IP address, but maybe you want to limit by user account. So that way, if a user is logged in from 2 different IP addresses, you still rate limit that user even though they're calling your API for multiple things. Yeah. And let's see. Yeah, last thing I'll do is I'll set up my own API key. So I'm going to do this. I'm going to create an object called API keys. And this is, again, this is just like in memory. Of course, you would like want to put these API keys in a database. Maybe you could associate them with a user or something like that. But I'm going to have, would I create a rotating key? Possibly. You also could just do like GUID IDs as your API keys, as long as they're not guessable and they could be looked up in your DB. And technically, if you're already using auth, you could use something like a JSON web token. What's up, Flu? Welcome to the show. But actually, I'm going to do this. I'm going to create a new map. We learned about a map earlier. But maps are basically like objects, but they're nicer. So I'll do API keys.set 1, 2, 3, 4, 5. I'm going to set that to true. So this is basically going to be a map of all valid API keys. And happy Wednesday to you, Milky Dev. Thanks for being here. But this is all valid API keys. And then I could write my own custom middleware that checks to make sure that there is an API key in the request. So I'm going to create my own middleware here with recres and next to validate the header. So I'm going to say the API key comes from the header x-API key. So I'm going to require users that are calling my API to specify a header called x-API key, and then I'm going to validate that. So I'm going to say if API keys dot has this particular API key, then we're just going to call next. Then that means everything's good. Go on to the next middleware, which is actually going to make the API request. Otherwise, we're going to throw an error, or we're going to forward an error. So we're going to create a new error, and we'll say invalid API key. What's happening, John, is content. Content is happening right now. So we have this error, and then whenever you call next with an error, or with a parameter, that actually will skip all of the request handlers below it, and that'll go immediately to my error handling middleware, which will just respond with an error here. So what we've done with this is in this middleware, we're checking for our own API key. So we want to make sure that anybody that requests our API is using the API key 1, 2, 3, 4, 5. And if they're not, we're going to respond with an error. So now in Insomnia, if I make this request, it should give an error. Invalid API key. But if I specify the x API key header, and actually, if I put it to something wrong, it should still say invalid API key. But if I set it to that API key 1, 2, 3, 4, 5, we then actually get back the response. And as you can see, I actually put that API key validation middleware behind the speed limiter and the slowdown, because if somebody is trying to just brute force API keys, it's gonna take longer and longer for them to be able to validate if they're brute forcing in the right way, because this API key validation is behind the limiter and the rate limiter and the speed limiter. Cool. Now, like I mentioned, you would want to store these API keys in a database. Maybe you could also validate by user. All that good stuff. Right now, it's super simple. It's just looking in the map, but this gives you an idea of how you would do that as well. I think Yeah, so the middlewares in this case go in order. First, rate limit the number of requests by IP address, then increase the response time based on the number of requests that IP address has made in the last 30 seconds, then validate the API key, and if all is good, we'll do this. And if we've cached the data, we're just going to respond with our cached data, and if we haven't, we're going to actually make the API requests. Great. No, they wouldn't. So if two people with different API keys try to access, they're going to be rate limited initially by their IP address. So as long as they're calling from two different IP addresses, then they will not be rate limited. The request will just basically happen. Yeah. Cool. I think that's it. Thanks everyone for watching this. And this all started from the question, which was, how would you secure an API without any sort of user login? I think I would start here. I would basically say, cache your data for one, because that will prevent you from running out of your quota limit for some API that you're calling. Number two is do rate limiting by IP address, and then also slowdowns by IP address. And then beyond that, you can start to implement your own authentication on top of your API, which is setting API keys, or potentially even checking to make sure that a user is logged in. But ultimately, this endpoint that we've created, you can now create a front end behind this. You could create a React app or a Vue app that shows the Mars weather, but it doesn't exhaust all of your available quota for the NASA API or whatever API you're hitting. Cool. Thank you everyone for watching. I'm sure I missed a lot of questions and stuff, but I think I'm gonna acknowledge the follows. I